Okay, the 2011 Parametric FRQ. So we're given, in this problem, we're given both of the derivatives. We're given dx dt and dy dt. And then we're also given a point here. So that point is probably going to help us find another coordinate later in the problem. So question A, find the speed of the particle at time t equals 3 and find the acceleration vector. So again, we are just going to use our calculator for both of these. Both of these are worth just 1 point, so it's about the answer that we get. So for the speed, we're going to do x prime of 3 squared plus y prime of 3 squared. And then the acceleration vector is going to be x double prime of 3 and y double prime of 3. So let's talk about how we can use our calculator effectively for that. So what I did before I started taping here is I put the derivatives into y equals. So I've got x prime in y1, y prime in y2. So to get the speed, we'll do the square root, and then I've got to bring up x prime of 3, square that, plus y prime of 3 squared, and then let's hit enter, and that gives us 13.006 or 13.007. Either of those would be acceptable. Now, for how do we do the acceleration quickly? Okay, we're not going to want to do any derivatives by hand. We want the calculator to do the work. I'm going to do math 8, which brings up the derivative with respect to x of my first derivative, or my first function, that's x prime of t. So I'm taking the derivative of that, which is x double prime, plugging in 3. And we get 4 back for that vector, or for that component of the vector. And then the next one, I'm going to do the exact same thing. I'm going to bring up math 8, x, but now I'm going to use my y prime, because I'm finding the derivative of y prime, and plugging 3 in. And we get negative 5.466, or we could also have 4 comma negative 5.467. So 1 point for each of those. Speed and acceleration, those should be easy points to get. Question B. Find the slope of the line tangent to the path of the particle at time t equals 3. We're looking for dy dx at t equals 3, which means we're looking for y prime of 3 over x prime of 3. This is a 1 point question, just using our calculator. I'm going to look for alpha trace y2 of 3 divided by y1 of 3. Again, that's y prime over x prime. We get a number back, 0.031 or 0.032. And again, that question was just a point. Question C. Find the position of the particle at time t equals 3. When it says find the position, we're looking for the x and the y coordinate. Okay, so what position meaning we need a point. We need an x and a y. We are going to use this initial point that was given to us. So we're going to set up 2 integrals. We're going to have an integral for the x coordinate, and we'll also have an integral for the y coordinate. I'll start with the x coordinate. I'm going to do the integral of dx dt. And the endpoints I'm going to choose are going to be from the point I have to the point I'm looking for as far as the t goes. So from 0 to 3, and then this will equal x of 3 minus x of 0. Now the x the derivative here, we're going to get this on the calculator. So I'll plug that number in, or I'll do that integral. Math 9 from 0 to 3 of dx dt, which I have in y1, dx, and we get that that's equal to 21. So 21 is equal to x of 3, and then x of 0 we're told is equal to 0. So that means our x coordinate is 21. We're going to do the exact same thing for our y coordinate. We're going to do an integral from 0 to 3 of dy dt, which would be y of 3 minus y of 0. So again, we're going to do the integral on the calculator. So I'll do math 9, 0 to 3 of y2. For that, we're going to get 0.77, we'll just say 774, equals y of 3 minus y of 0, which was told to us to be negative 4. So I'll do a plus 4 here. So that means y of 3 is equal to this number we had on the calculator minus 4, which is negative 3.226. So our point, you can say at t equals 3, the position is 21 comma negative 3.226. This is a 4-point question. So here's where the point comes from. Setting up the integral for each coordinate is a point. And then actually getting each of these is the other point. So that's the 4 points. So all in now we're at 7 points for this problem. And we're moving on to question D. Question D says, find the total distance traveled by the particle over 0 to 3. So super straightforward arc length equation. The integral from 0 to 3 of the square root of x prime of t squared plus y prime of t squared. And all we have to do is plug this into our calculator. Again, I've got x prime and y1, y prime and y2. So I will go to math 9, 0 to 3, the square root of y1 squared plus y2 squared dx. And we get 21.091. This is a 2-point question, a point for the integral and a point for the answer.